Yeah, I know, we're covering these guys again. We're about halfway through.
I've been reading through our textbook, and they keep giving great examples of how creatures change, like Darwin's finches, or these tortoises. But this isn't evolution by natural forces if these animals were programmed to adapt like that.
Unless, of course, they were naturally programmed to adapt like that.
I see what you're saying. Many evolutionists consider any change as evolution.
Well, evolution is any heritable change. That's the definition of evolution.
Which makes it seem like we're always evolving upward.
No, not at all. Evolution has no direction, but evolution by natural selection moves towards more fit to survive. If we have to regress to be better able to survive, then we very well can.
But not all changes come from accidental errors through mutation. Some pre-programmed variation helps animals adapt through genetic recombining.
That's not change, though. Pre-existing genetic variation is just that, pre-existing. So whatever comes out of genetic recombination isn't change and isn't evolution. Unless, of course, that genetic variation came from, say, mutations. So are organisms not programmed by mutations and natural selection?
This page lists the two main sources of change as mutation and genetic recombination.
So mutations would be accidents, errors?
Not necessarily, just changes in genetics.
Right. Mutations are usually caused when there's an error copying a creature's genetic information, which is found in its DNA. It can lose, duplicate, or even copy letters in the genetic code.
What's the difference between duplicating and copying letters? And there's more it can do than that. There are insertions, deletions, substitutions, translocations, and inversions.
But if I delete, scramble, or duplicate letters, won't I eventually get a new word?
Well, genetic material isn't a language. It doesn't work in words.
Sure, but a new word doesn't necessarily mean anything.
So if I scramble the letters in puppy, it just means gibberish?
Exactly. Mutations might be able to create a new combination of letters, but it needs to have a meaning for the cell to use as a blueprint later on. In other words, a code isn't really a code without some assigned meaning.
Says who? No matter what order the nucleotides are in, it will still create a protein, or whatever it's making. It doesn't have to have a meaning, it will just change the specifications of what the DNA is forming.
Gibberish can't create anything.
Gibberish DNA can create gibberish proteins, but not all mutations create gibberish. Mutations can actually affect the organism's characteristics. If this so-called gibberish is a bad thing, then natural selection will weed out the gibberish mutations, leaving the meaningful ones, which can indeed form at random, especially with a selection method.
So mutations are always bad?
Yeah.
No.
Look at what it says. Some mutations, such as those that cause genetic diseases, may be lethal. Other mutations may lower fitness by decreasing an individual's ability to survive and reproduce. Still, other mutations may improve an individual's ability to survive and reproduce.
You do know that that contradicts what you're saying, right?
It looks like they agree that mutations are bad.
No, they're saying that some mutations are bad. Can you read?
But then why do they say some may improve an individual?
Because they can. He goes on to give examples of beneficial mutations and states that they are all deletion mutations, which is kinda true for those examples, but he fails to realize that this does not disprove the fact that genetic insertions and duplications do exist.
But if a population of creatures continues to lose information, could it be deadly for them?
Yeah, of course. Any type of mutation can be deadly, even excessive addition of genetic material, which is essentially what Down syndrome is.
Bingo! But here's the real problem. People count on that loss of information from mutations to create the genetic blueprint for every living creature on Earth out of nothing. That's crazy.
Yes, your straw man version of evolution is crazy, but you still have yet to disprove the fact that mutations that add genetic material can be beneficial. And even if they can't, you can have gene duplications that don't have any effect, and those duplicated genes could then go through mutations and end up with more genetic material. You're completely ignoring the many types of mutations that we know exist.
No way, that's so impossible. It destroys evolution.
Right?
No, it destroys your straw man evolution that only has less than half of all of the actual mutations that we see.
Most heritable differences are due not to mutations, but to genetic recombination. So, God not only created all the animals, he also packed them with enough genetic information that would allow them to adapt to different environments and varieties we see today.
Well, not quite. Genetic recombination only works with existing traits in a species, so the species has to already have diverse genetic information for recombination to be a thing, which they can't if we are to believe the Bible. That's because in the flood myth, only 2 of every unclean animal, 8 humans, and 7 of everything else survived the worldwide flood. Ignoring the fact that we need at least tens of thousands of animals in a species in order for it to be possible for them to survive, how could 2 dogs, since dogs are unclean, account for the wide genetic variation that we see today, since mutation is the only way that genetic variation can increase?
So a population of animals can adapt by expressing variety over time, but there are limits to how much they can change.
No, because their genetic information is not limited when it can change with mutations. If they did have finite genetic information, then dogs could only look like the 2 dogs that were supposedly on the ark, right? You haven't exactly disproved critical types of mutations.
And you know, I used to think that all these arguments really showed evolution, but then I got to thinking. Studying changes in a beak shape, like Darwin's finches, won't show you where that beak came from.
But you know what does? Comparative anatomy, comparative genomics, and the fossil record. You know, science.
And despite the minor changes, a finch is still just a finch.
But it probably won't still be a finch in a billion years. But I guess that's something that you just can't understand.